In this video, I am going to explain LPP using Simplex method. See, there are many algorithmic method to solve LPP. Here I am going to explain LPP by using Simplex method. See the problem. This is the maximization problem. Z which is equals to 12x1 plus 16x2 subject to 10x1 plus 20x2 less than or equal to 120. 8x1 plus 8x2 less than or equal to 80, x1 and x2 greater than or equal to 0. This problem is maximization problem. Objective function is z which is equals to 12x1 plus 16x2. So first we need to write only this one, maximization objective function. So the subjected to two constraints are there. One is 10x1 plus 20x2 plus s1. S1 means a slack variable first, which is equals to the solution is 120. Second constraints 8x1 plus 8x2 plus second slack variable, which is equals to solution 80. So how many variables are there here? x1, x2 and slack variable, these two, s1 and s2, that should be greater than or equal to 0. For each constraints you need to add one slack variable in order to balance the constraint. Here we need to add these two constraints in the objective function. See, here we need to add the two slack variables in the objective function, that is s1 and s2. Let us see how I am going to frame the initial simplex table. See, CBI is there. CBI is nothing but coefficient of basic variable. CJ is nothing but coefficient of objective function. So coefficient of objective function is 12, 16, 0, 0. This one. 12, 16, 0, 0. This is the objective function. We are adding two basic variable, that is S1 and S2. For S1 value is 0. For S2 value is 0 here. Next, for first constraint, the value of x1, variable x1 value is 10 here. For x2 is 20 here. S1 we need to put 1. For S2 there is no slack variable of second. S2 is not there here in the first constraint. We need to put as a 0. The solution of first constraint is 120. Next, second constraint. For x1, the value, the variable value is 8. For x2, 8. S1 is not there. We need to put as a 0. For S2 is 1. The solution of second constraint is 80. After writing S1 and S2, we need to find out ZG value. ZG value, how to find out? For this, formula is there. That is ZJ, which is equals to summation I equals 1 to 2 CBI into AIJ. So now we need to find ZJ value. Formula for finding ZJ is this one. Look at this formula. But I am going to use a simple way to find out ZJ value. See the first value here. See ZJ. I am finding 0 into 10 plus 0 into 8, we will get 0. That we have to write it here. The same way we need to find out for all the elements here. 0 into 20 plus 0 into 8, we will get 0. 0 into 1 plus 0 into 0, we are getting 0. Similarly, 0 into 0 plus 0 into 1, 0 only. Similarly, we need to find out for solution also. 0 into 120 plus 0 into 80, 0 only. After finding ZJ value, since our CBI value is 0, so all the ZJ values will be 0 only in the initial simplex table. Always in the initial simplex table. After finding ZJ, now we need to compare CJ and ZJ. Compare Cj and Zj. Formula is Cj minus Zj. So Cj is coefficient of objective function. That is 12, 16, 0, 0. Zj values are 0, 0, 0, 0. Compare the values, you will get the Cj minus Zj. See, 12 minus 0, 12. 16 minus 0, 16. 0 minus 0 is 0. 0 minus 0 is 0. This is the value of, we are getting Cj minus Zj. Here we need to allocate the maximum value. The maximum value is 16. 16. So we need to allocate the column here. So this column we need to consider as a key column. After allocating the key column, we need to find out the ratio here. So look at the solution, that is 120. 120 we need to divide it with the key column element, that is 20. Similarly, for this solution is 80. So for this 80 we need to divide with the key column value, that is 8. Corresponding key column value is 8. For this solution, corresponding key column value is 20. So we are getting 6 here. So we are getting 10 here. So minimum value E, we are getting the ratio value here. In this we need to allocate the minimum value. The minimum value is 6. So this 6 we need to allocate this row by using this. So this row we have to call it as a key row. This is key column. This is key row. Intersection point we have to call it as key element. See, we are getting look at the optimality conditions first. Before going to the next step, we need to see the optimality condition. Optimality condition is says for maximum always Cj minus Zj is greater than or equal to 0, which means 0 or either it should be negative. For minimum, always Cj minus Zj should be greater than or equal to 0, either it should be, which means either it should be 0 or positive. Our problem is maximization problem. So our Cj minus Zj answer should be 0 or negative. Here we are getting all positive values. Positive values we are getting means this optimality condition of Cj minus Zj value should be 0 or negative. Here we got positive value. So we didn't raise the optimality. So we need to proceed further step to reach the optimality. In order to proceed further, first step is to select the maximum value Cj minus Zj, that is 16. This column is called key column. After finding key column, next step is you need to find the ratio, that is ratio between solution and key column. First solution is 120, no, so 120 divided by 20 you will get 6. Same way for second row, 80 divided by 8 you will get 10. In order to find the key row, select the least value in the ratio column. Here 6 is the minimum value. This row is called key row. This intersection point we are called it as a key element. Then x2 is leaving, x2 is a entering variable, S1 is leaving variable. What we are allocating that column, key column, that we have to in the next step we need to write as a this x2 will be entering variable. In the next step S1 will be the leaving variable. Let us see how I am going to frame the first iteration. This is the first iteration of see, this is the first iteration how I am framing. This is a Cj. Cj is objective function 12, 16, 0, 0. Basic variable x1, x2, s1, s2 as it is there. Solution, ratio, that column also as it is. We need to write here. Look at this one. Initial, and you just compare here. x2 is the entering variable. S2 is entering variable means this x2 will be coming in here, entering. S1 should be leave. S1 should be leaving variable. X2 should be entering variable. X2 and S2. For X2 variable is 16. That we need to write it in SBI column. For S2 variable is 0, that we need to write it here. So now we have to frame the values here by using the formula. See, this x2 is entering. So the x2 means this one, 10. Old row you just see 10 here it is there. That value we need to divide with the key element. Key element is 20. 10 divided by 20, half. 20 divided by 20, 1. 1 divided by 20, 1 by 2. 0 divided by 20, 0. Next solution, 120 divided by 20, value is 6. Next, this S2. S2 is, this is the old value. We need to frame the new value by using the formula. What is the formula for finding the new value? This is the formula for finding new value. New value, which is equals to old value minus corresponding key column into corresponding key row value divided by key element. First, old value, just see 8 is there. 8 minus corresponding key column. Corresponding key column is 8 into corresponding key row is 10 divided by key element. You will get 4. Similarly, next value. After you are getting 4 value, that should be, you have to enter in the first iteration. That is 4. Next, old value 8 minus corresponding key column value. Corresponding key column value here 8 only into corresponding key row is, corresponding key row 20. 20 whole divided by key element 20. You will get 0. That 0 you need to write it in the first iteration. Similarly, 0 is the old value. 0 is the old value minus corresponding key column into corresponding key row 1 divided by key element. You will get minus 2 by 5. So similarly, in the same way we need to find out next values. You will get 1 here. Then for solution also you need to find out. You will get 32. After finding the new value, you need to allocate, you need to find out Zj. Zj I already told. Zj how you will find out? 16 into 1 plus 16 into 1, 16 into half plus 0 into 4. You will get 8. 0 into 4, 0 only. 2 8s are 16. 16 into 1 plus 0 into 0. What will be the answer? 16. So next, similarly, 16 into half plus 0 into minus 2 by 5. You will get 4 by 5. 16 into 0 plus 0 into 1, 0 only. So after finding Zj, you need to find out, you need to compare Cj and Zj. The formula is Cj minus Zj. 12 minus 8 is 4. 16 minus 16 is 0. 0 minus 4 by 5 is minus 4 by 5. 0 minus 0 is 0. After finding Cj and Zj, we need to allocate the maximum value here, that is 4. Why we are not allocating this? Because this is a negative value, this is a least value. After finding, we are allocating the maximum value, along with we need to allocate the column here. This is key column. After finding key column, we need to find out the ratio here. The solution here, what we are getting? 6. This 6 should be divided with the corresponding key column value, that is half. That the answer will be 12. Next, this 32 is the solution value. 32 divided by 4, we will get value is 8. After finding this ratio, we need to allocate the minimum value here. The minimum value is 8. You need to allocate the row. So after allocating the row, this is a key row, this is a key column, this is the intersection point, we are called it as a key element. After finding this, you look at the Cj and minus Zj value. Here we are getting any 0 or negative values. Yes, we are getting 0 and negative values, but this element should be in a positive. So again we need to go with the next iteration. So the optimality condition is says Cj of minus Zj value should be 0 and or negative values. So next second iteration. Second iteration, same table we need to plot. So here x1 will be the entering, x2 will be leaving variable. x1 is entering, s2 will be leaving variable. So x2 you need to write, x1 is entering here, Cj is common, basic variables also same, but here we need to find out the new value by using the formula of this one. So this x2 we need to find out the new value here. This new value how to find out? By using this formula we will get these values. Then this s2 we need to divide with the key element. 4 by 4 1, 4 by 4 1, 0 by 4 0 by 4, answer is 0 by 4 is 0 only. Minus 2 divided by 4 whole divided by 4 we will get minus 1 by 10. Then 1 divided by 4 1 by 4. Next 32 divided by 4 we will get 8 here. After finding these values we need to find out the Zj value. Zj value how to find out? 6 into 0 plus 12 into 1 we will get 12. 16 plus 1 plus 12 into 0 that is 16. 16 into 1 by 10 plus 12 into minus 1 by 10 we will get 2 by 5. 16 into minus 1 by 8 plus 12 into 1 by 4 we will get 1. After this similarly we need to find out for solution also. 16 plus 2 plus 12 into 8 we will get 128. After finding these two we need to compare Cj minus Zj by using the formula, that is Cj minus Zj. 12 minus 12 is 0, 16 minus 16 is 0, 0 minus 2 by 5 is minus 2 by 5, 0 minus 1 is minus 1. Look at the Cj minus Zj. Just remember the optimality condition. We are getting the value of Cj minus Zj is 0 and negative values. So we need to stop here. We satisfied our optimality condition. So we are getting the value of x1 is 12, x2 is 16. The Z optimization value is 128. So this is the answer.